January 1st, 1983. That's the official birthday of the internet. Doesn't seem that long ago, does it? Yet life is dramatically different.
Facebook opening for trade.
The World Wide Web is now more connected than ever before.
Older adults are using virtual reality to stay connected.
And there's a lot more to come. Self-driving cars, autonomous robots, a virtual world. A future that will happen at the edge with a very different type of connectivity.
What we're looking for now is more agility in our networks to be able to react more quickly to the customer needs and to things like the large peak loads that we see from big streaming events. Low and predictable latency is becoming more and more critical to their experience.
It's something operators have traditionally struggled to deliver.
These architectures are traditionally quite statically designed and built.
And built on technology that was difficult to change.
A new network architecture could revolutionize that process. Intel and Vodafone have developed a cloud-like fixed access architecture for the broadband network that essentially moves the network to software, enabling quick network upgrades while delivering
Huge bandwidth, really low latency, really close to the customer, almost at the last mile.
It does that by deploying cloud applications and network services on the same platform in a variety of edge locations. Not only will operators be able to efficiently manage the traffic on their network, but they'll also be able to deliver customized services to the customer, enabled through steering capabilities built into the architecture.
We could enable particular early innovation capabilities on particular customers' lines.
This should enable more low latency applications, things like cloud gaming, things like 4K video, things like augmented reality and virtual reality.
Like the Google Cloud today, where they can just drop in new applications and you get almost instantaneous access to them. I think operators using this technology will be able to do the same thing.
Soon, Vodafone will deploy this architecture in its networks. It follows an innovation cycle that began in 2018, a time that coincided with a dramatic shift in the way consumers and businesses came to rely upon broadband.
The massive migration online is putting our internet infrastructure to the test. In Seattle, one of the coronavirus hotspots, internet usage has spiked 40% in the last week alone.
How does this technology reflect those demands on the network?
We spoke with operators, and I think Vodafone were probably, they had the best vision we saw for how this technology could help. So they, first of all, the ever increasing importance of broadband networks through the pandemic, it made them realize they had to move to a more, flexible architecture that would allow you to upgrade it more quickly, add new services. Again, there's a proliferation of edge compute everywhere now. They wanted access to that. They wanted ways to break out to those new edge services. And then the other part was the operational efficiency.
Operators had to quickly build out their networks to support the increased broadband demands. At the same time, calls to make networks more efficient in their power management and energy consumption were continuing to grow. The telecom sector reportedly accounts for 1% to 2% of all energy consumed globally.
There is a huge energy drain through the broadband network. There are a lot of devices out there. It's fairly heavy grade equipment. There's a lot of fiber in the ground that's lit up. And how do you basically more efficiently manage that?
It's a challenge that Intel and Vodafone tackled through its solution.
Operators would generally over-provision on network capacity, which adds inefficiencies and high power consumptions into the network.
This architecture changes that.
You can literally turn off servers, or you can bleed traffic onto a single CPU in a 2 CPU server and turn off the CPU, or you can even get more granular to that. So today, on an Intel Core, which is the building block of a CPU, you can do about 10 gigs worth of broadband traffic. So you can scale on that type of, say, step metric now, a 10 gig core, and you can right size your equipment and your network based on that type of granularity.
It does that through unique components built into the network architecture.
So the first change that we need to make is around the control user plane separation of our broadband service gateways. So this splits how we authenticate and manage each subscriber from how we deliver their data traffic through the network. Making that split allows us to more flexibly support the services and the most appropriate mix of hardware and software solutions from our suppliers. and helps give increased resilience capabilities into the network over and above what's achievable today. As well as that, we then look to deliver programmatical capability to influence how we serve each subscriber's traffic in the network. And that allows us to direct how we take their traffic to the service gateways and meet their sort of service latency and capacity needs. And then finally, an important part from the maintenance operations of the networks is that we need the ability to rapidly in-service, upgrade the capacity and add service nodes without any impact to customers. And we're talking about potentially changing the speed for upgrades from what would initially have been weeks or months to days or even hours.
The architecture arrives on the market as telcos face new pressures to deliver services to the enterprise. A customer base that opens up new revenue streams for telcos as consumer subscriber growth remains stagnant.
The possibilities for them, the options for them are other kinds of fields, such as advanced video, such as gaming, other kinds of applications where the market isn't saturated already with competitors.
It's clear that the telco market is quickly evolving, already under pressure to meet the broadband demands of hybrid work and online video. Operators must now think about how to position themselves for a competitive future. A future that will one day see a single unified communication system. It's a merger that will enable a consistent customer experience across mobile and broadband devices.
By adopting this type of technology in this part of the network, we're very confident that we'll be able to offer true wireline and wireless convergence in the same platform, in the same location.
It's a glimpse into the potential that could come with this technology, outcomes that will soon unfold when Vodafone rolls out this architecture in its network.
Probably the most exciting part, though, is what we don't know yet. The applications and solutions that customers are looking for in the future that nobody's really imagined.
I think everybody working in technology, what you want to see is your technology adopted. And it's fantastic that this is starting to happen.
The biggest challenge is doing something new, doing something that hasn't been tested before.
It'll be interesting to see what happens next.